Depend on where you are watching. It's okay. Yeah. Tonight we'll be looking at logarithmic differentiation. As long as you know how to differentiate, there is no problem. It's not difficult. It's simple as ABC. Is that clear? But I know very well that you were taught elementary algebra in first semester. They taught you logarithmics, two of us, using the laws of logarithmics to evaluate any given log examples, two of us. Yeah. So tonight we are going to make use of those examples. Let me take us back to our algebra. We know very well that the three laws of log, we know that if we have log AB, this is the same thing as what? Log A plus log B, true or false? Do you agree with me? 2. If we have log A all over B, this implies that this is log A minus log B, true or false? Then 3, if we have log A raised to power n, this is the same thing as n log A. Do you agree with me? Excuse me. You agree with me, right? Okay. So if you agree with me, please try and wake others to be part of this class. It will help them. So if you agree with me, now I want to use this in terms of differentiation. So in terms of differentiation, as long as differentiation is concerned, instead of this, the 1, log 1 will now be, instead of log, is going to be in open bracket AB. This is equals to AB plus in B. Then 2, instead of log A all over B, is going to be in open bracket A all over B. This is equals to in A minus in B, right? And 3, instead of log here, is going to be in A raised to the power of n equals to n in A. Do you agree with me? So we should take note of this. Is that clear? As long as differentiation is concerned, we'll be using these 3 laws. Is that clear? While we know that we use this basic law when we're taught algebra, 2 of us. But as long as calculus is concerned, we'll be using this. Do you understand? So we'll fix idea with an example tonight. We'll fix idea with an example. So let's go ahead to fix ideas with examples. Yeah. So I want us to know these basic things. If we have example, if y equals to in x, we are asked to find dy all over dx, or we write solution y all over in x is going to give us our dy all over dx is equals to 1 all over x. Is that clear? If you differentiate in x, you are going to have 1 all over x. It's very important. Take notes. Amen. Okay. So, do you agree with me? So, this is the answer. This is whenever you see you are given a function to differentiate y equals to in x. Note that in x will always give you what? 1 all over x. Okay, so let's consider another examples. What if you are asked to differentiate in 2x? Y is equals to in 2x. So for us to differentiate in 2x, just look at it this way. We have in 2x, right? So just assume that this is how it is. Is that clear? So if you differentiate 2x, you are going to have what? 2 all over what? X. Is that clear? So you are going to have our dy all over dx is equals to 2 all over what? X. So supposing here is 3, let us say y equals to in 3x. What are you supposed to have? You are supposed to have dy all over dx, because if you differentiate 3x, you have 3. You need to divide x. This is 3 all over what? X. Are you following? Do you understand? Are you following? Do you understand, right? Okay. So we can proceed, right? We can proceed, right? Okay. Let's proceed to consider. Okay, I want you to look at this. What if we have y equals to in 6x? Then we are asked to find dy all over dx. Yeah, somebody should tell us the answer. I'm waiting. What is the answer, please? What is the answer? 6 all over, yeah. Kenneth, Peter, I love that. I love that. It's okay. Yeah. So, is it difficult? No. It means, please don't forget to write dy all over dx all over dx equals to 6 all over x. Don't forget to write it this way. Exactly. Don't just write 6 all over x. You understand? you just write 6 all over x. Nobody know what you differentiated from. But by the time you write the value over x is equal to 6 all over 4, 6 all over x, you know what you are talking about. It's okay. So let's consider more examples. If y equals to in open brackets t plus 1 and you are asked to find dy all over dt. It's simple as ABC, right? Our y is equals to in open brackets t plus 1. So our dy all over the t, sorry, not the x, the t is going to be what? 1, because if you differentiate t plus 1, you are supposed to have what? 1. So use it to divide this. This is t plus 1. So 1 all over what? T plus 1. Any question, please? Any question? Drop it in the comment section. If you have any question. Do you have any question? Any question? No question? So you mean I can proceed, right? Any question? Please let me know if there is any question. Waiting for you guys. Is there any question? No question. Are you sure? Okay, there is no question. Go ahead to differentiate some problems. Is that clear? Okay. There are no questions. Let's proceed, right? Let us proceed. I have here some questions. Here. If y equals to open bracket t plus 2 raised to the powers of t, and say find the y all over the t, is simple as ABC. Is that clear? So what you will do is you write solution, then y is equals to t plus 2 raised to power t. So you take log on both sides. Is that clear? When you take log on both sides, take log on both sides. It means in y equals to in open bracket t plus 2 raised to the powers of t. Right? Do you agree with me? So look at the right hand side. Which of the law is applicable? Which of the laws is applicable here? Somebody should tell us. Look at how it is. Which of the law is applicable here? The applicable law here is the third law. It says that if we have a raised to the power of n, this is the same thing as n in a, true or false? So it means we are going to have in y is equals to t in open bracket t plus 2, right? Okay, so when we differentiate in y, what do you suppose to have? You're supposed to have 1 all over what? Y, true or false? But we are differentiating with respect to t, so here will be 1 all over y dy all over dt equals to t in open bracket t plus 2, right? Okay, when you come across functions like this, what will first come into your mind? Go back to your rules for differentiation. Look at the board, everybody. Go back to your rules of differentiation. When you come across functions like that, what will first come into your mind? Look at it again and again. It means you are going to use what is called product rule, true or false? Because we have two functions there. We have two functions here. So to consider the right hand side, we use product rule, true or false? Using product rule, on the right hand side, right? Okay, so it means this is y equals to uv. So here will be let u be equals to t and v be equals to in what? In open bracket t plus 2, right? So differentiate this, our d all over the t is 1, right? Then our dv all over the t is equals to 1 all over t plus 2. True or false? Amen? Okay. So if you agree with me, don't lead the prophet, tell you, you agree with me, our product rule, that is our dy all over the t equals to v du all over the t plus u dv all over the t, right? So far so good. So here will be our dy all over the t is equals to, what is our ordinary v? Ordinary v is this, in open bracket t plus 2 times the v all over the t is 1 times 1, right? Times 1 plus ordinary u is what? T. Then t times the v all over the t is 1 all over t, right? 1 all over t plus 2. True or false? Yeah. True or false? It is true. True or false? Zakari. Good evening. Where are you watching from? Which country? Okay. Can we proceed? Any question? Jakari, Sai, which country are you watching from? Oh, Kenneth said I should take it again. Yeah, from product rule, right? It's okay. From the product rule. Yeah. Okay. When ordinarily, if you see functions in this form, t plus 2, what will first come into your mind? Assuming you are asked to integrate differentiate this function. This is t. It means this is an one function. Then we have in t plus 2, close bracket. This is another function. So it means you are going to make use of what? The product rule. So the product rule, this is the formula, true or false. When you look at it, uv, isn't it? So looking at it, you now say let u equals to t and v equals to this. True or false? So what left? For you to differentiate this t with respect to this function with respect to t, it will give you 1. Then when you differentiate the v all over, this is in t plus 2. Is it not 1 all over t plus 2? True or false? It's the truth. So what left? You have to substitute this, and this into the formula. And this is what you will have. Amen? Yeah. So the final answer supposed to be our dy all over the t is equals to 1 times this is what? In open bracket t plus 2 plus 1 times t times 1 is going to be t all over t plus 2. Yeah, this is what you are supposed to have. True or false? It's true, right? So any other question? Is there any question? Is there any question? There is no question. Can I clean the board so that we move further to solve other questions? Is that clear? Okay. Yeah. Oh, we are not done. No. You know why? We just differentiated this. The left hand side, true or false? No, sorry, the right hand side, true or false? To obtain this. What about the right hand side? Can I take out the... So, this is what it's supposed to... This is how it's supposed to look. So this implies that 1 all over y dy all over dt is equals to this. We got this, true or false? From this we obtain this in open bracket t plus 2 plus t all over t plus 2. Then when we cross multiply, because we are looking for dy over dt, not 1 all over y dy over dt. So when we cross multiply, the left answer will now be dy all over dt is equals to y open brackets in open brackets t plus t all over what? T plus 2. Then close the bracket. You now ask yourself, what is y? And y is given as what? Y is given as this. Raised to power t. True or false? Yeah, so here, instead of y, we write this function. We write this function. Yeah. Write this function. Our dy all over dt is equals to t plus 2 all in bracket raised to power t. Instead of y, this is what we are going to write in open bracket t plus 2 plus t all over t plus 2. So this is the final answer. Any question? Any question? Hope you are following. Any question? If there is no question, let us proceed. If there is no question, tell me so that I can proceed. Right? Any question? No question. So let's proceed further to look this person, you are just coming, you say you don't understand, you came late. So wait for the next example. We do it together. You are just coming. Okay. Let's look at questions like this. If y equals to 3x raised to the powers of 4x plus 1, find dy all over the x. It's simple as ABC. You know, when you come across questions like this, what you need to do, you take log on both sides. Is that clear? So now write taking log on both sides. Is that clear? Okay. So if we take log on both sides, we are going to have in y equals to in 3x raised to the powers of 4x plus 1. Amen. Then, which of the law is applicable here? The third law, isn't it? So the third law, we now write note that, to remind us, note that in a raised to power n is the same thing as what? N in a, true or false? Right? So in y is equals to 4x plus 1 in 3x. True or false? Yeah, put it inside the bracket. So when you come across functions like this, what will first come into your mind? Look at the board. Somebody should tell us what to do. Tell us on what to do, please. We are going to use product rule, true or false? Product rule, right? We use product rule, right? Okay, so let's use the product rule on the right hand side. If we differentiate the left, we are going to have 1 all over y, the y all over the x. Then differentiate the right hand side, differentiating it direct, it will do you good so that you not take your time, right? So if we differentiate it direct, amen? If we differentiate it direct, it means we are going to roll in 3x, differentiate this, to differentiate 4x plus 1, we are going to have what? 4 times in 3x, then plus whole 4x plus 1, differentiate in 3x, then any answer use it to multiply. So you are going to have 3 all over x times what? 4x plus 1. True or false? So far so good. So we cross multiply. Our y will now be the y all over the x because y open bracket 4 open bracket in 3x. Don't write 4 times 3x to give you what? 12. Please take notes. You leave it like this. Then plus use this to multiply. This is the same thing as 3 open bracket 4x plus 1 all over what? X close the bracket. Then what is y? We cannot just leave it like this. Y is given as what? This idiot, right? Amen. So our dy all over dx is equals to, we write back the formula instead of y, 3x raised to power 4x plus 1 open bracket 4 open bracket in 3x plus 3 open bracket 4x plus 1 all over x. Yeah, this is what you are supposed to. Any question, please drop it in the comment section. Sorry for the break in transmission. Do you have any question, please? Any question? From note that, okay, I'm coming. I think you are just coming. That is why you are asking me that question. I think you are just coming. I discovered that you are just coming. So your question, I'll come and explain it. Okay, yeah. Uh, yeah. Note that, in your algebra, you were taught if you have log a raised to the power of n, this is the same as n log what? A, true or false? But here, as long as calculus is concerned, we are using in A. So if we have anything of this kind, we can rewrite this idiot in this form. N in A, look at it here. In 3x raised to the power of 4x plus 1. True or false? So we now introduce this law 3, right? Then we bring it here. That is why you are saying in y equals to 4x plus 1 close brackets in 3x. Can you see now, my friend? Are you seeing? So when you see function of this form, you don't need a prophet to tell you. You know that you are going to use product rule. But that product rule will take us time, true or false. So you just differentiate it direct. You hold this, then differentiate 4x plus 1. You understand? So when you differentiate 4x plus 1, you are going to have what? 4. Then use it to multiply in 3x. Then plus, hold this, differentiate in 3x. When you differentiate in 3x, you are supposed to have 3 all over x times 4x plus 1. Then, here, we are looking for dy all over dx, right? We are not looking for 1 all over y, dy all over dx. So we have to cross multiply, right? So when we cross multiply, this is how it will be. Y open bracket, close bracket, this. Then what is y? Y is this function. 3x raised to the power of what? 4x plus 1, close bracket. Yeah. Any other question, please? Please, I want you guys to like. Hope you are sharing it. So, Abdul Ahmad, do you understand? Any question, yes or no? So that we can progress. Okay, if there is no question, let's proceed further. Okay, let's look at another question that you may see, because in your exam they will not say use logarithmic differentiation. You see how the functions look like. So you don't need a prophet to tell you when you come across functions of this form, that is what you are going to do. So now, another example, if y is equals to x root of x minus 1, then find dy all over dx, right? It's simple as ABC. What you need to do is just write solution. Y is equals to x root of x minus 1. Amen. Okay. So far, so good. So let's go back to indices. In indices, when you have square root of a, we can write it in this form, right? True or false? So what if we now have x root of a? It means this is the same as, sorry, this is 2, this is the same as a raised to the power of 1 all over x. True or false? True or false? Okay, so if you agree with me, we can write this idiot in this form: x minus 1 close bracket raised to the power of 1 all over x. Do you agree with me? Look at the board. Do you agree with me? The class is very scanty. It's only 18 students that are here. I don't know what others are doing. Okay, so let's proceed. Let us proceed. So it means our y will now be, open bracket, 1 all over. So what are we going to do? We take logarithms on both sides, right? So we now say taking log on both sides. There will be in y equals to in open bracket x minus 1 raised to the power of 1 all over x, right? So which of the laws is applicable? We now write that, note that in a raised to the power n is the same as what? N in a, right? Okay, so in y will be equals to 1 all over x, amen, times in open bracket x minus 1. True or false? So this is a product rule. We use product rule. Differentiate the left hand side, 1 all over y dy all over dx. Then differentiate the right hand side. Let's differentiate this and hold this, right? So when we differentiate this, we are going to have minus 1 all over x raised to the power of 2. True or false? Then times in open bracket x minus 1, close the bracket, then plus, hold this, differentiate in x, so you are going to have 1 all over x minus 1 times 1 all over x. True or false? Then we cross multiply our dy all over dx is equals to y open bracket minus 1 all over x squared in open bracket x minus 1, then plus open bracket 1 all over x minus 1 times 1 all over x, then our dy all over dx now be equals to, what is y? Y is this function, right? So x minus 1 raised to the power of 1 all over x, open bracket, okay, open bracket minus 1 all over x square times in open bracket x minus 1 close the bracket plus 1 all over x minus 1 times 1 all over x close the bracket. This is the final answer. Any question, please? Do you have any question? Oh, how can you identify? But they are not similar now. The logarithmic, the exponential functions, you always see something like this now. They are not looking alike now. It does not look the same. This is an exponential function. Sometimes you will see y equals to exponential x plus 1. Can you see the difference, Peter? Are you seeing the difference, Peter? Okay, so let's proceed further. Combine rule or chain rule, which one? Which one is combine rule again? Peter, which one is combine rule again? Can we proceed? Let's move further to chain rule. Chain rule. You cannot apply chain rule here now. Chain rule. You cannot apply chain rule. It is meant for logarithmic differentiation. Do you understand? You just differentiate, use logarithms whenever you come across functions like this. Chain rule functions are in this form now. Look at it. Chain rule functions are in this form. That x plus 1 raised to the power of 6, true or false? But this one, the independent variable, either raised to the power. So when you come across questions like this, you use logarithmic differentiation. Is that clear? Peter, do you hear me? Kenneth, Peter. I know you are the only student that is following me up. The rest, they are just, it's because of the notes they are even here. Kenneth, Peter, you are the only student that is following. God bless you for that. It's okay. Let's proceed further to consider more complex questions. Amen. Amen. More complex questions. Okay, we have here very good question. Very, very good. That will make us to use all the three rules that will make us to use all the three rules. If y is equals to x minus 2 all in raised to the power of then square root all over x plus 1 all in square open bracket 2x minus 1. Yeah, these are the types of questions you may likely see in your exam. Very important. Don't joke with this question. It's very important. Now say find dy all over dx. I will indicate if y equals to this, use logarithmic differentiation to obtain dy all over dx. I will definitely indicate it. Is that clear? But you have to listen very attentively. Are you following? You have to listen very attentively. Okay, so let's proceed. Let's proceed to look at it. So what we are going to do, we take log on both sides. When we take log, we are going to have in y equals to in open brackets square root of x minus 2 all in raised to the power of what? 3 all over x plus 1 all in square times 2x minus 1. Then close the bracket, right? So assuming we have a raised to the power 3, square root of a raised to the power, this is the same as a raised to the power 3, open bracket raised to the power of 2, right? Use this to multiply, we are going to have a raised to the power of 3 all over 2, true or false? Okay? So in y is equals to in open bracket x minus 2 raised to the power of what? 3 all over 2 all over x plus 1 all in square open bracket 2x minus 1. Then close the bracket. Amen? Okay. Who can tell us the first rule we are going to use? Look at the right hand side. The first rule, the first law, the first law. Somebody should tell us. Peter, are you still around? The first law. Third law, no. Look at your notes very well. I don't think it should be third law. Peter, is it the third law or second law? We are supposed to consider the second law that says, note that, amen, note that in open bracket a all over b is going to give us in a minus what? In b. True or false? True, right, class? Okay, so if you agree with me, the left answer will be y equals to in open bracket x minus 2 raised to the power of 3 all over 2, then minus, amen, in open bracket x plus 1 all is square times 2x minus 1. True or false? You know why I put this bracket? It's because of this negative sign. Because we are still going to introduce another law here. True or false? Look at it. We introduce another law here. Okay? So in y will now be equals to in open bracket x minus 2 raised to the power of 3 all over 2. Then minus, here we are going to use the first law. If we have in AB, amen, this is equals to in A plus in what? B. True or false? Yeah. Who is saying product true? You came late now. Oh, some of you are understanding. That is why you don't ask questions. It's okay. That is nice. Okay. So it means here now open bracket in x plus 1 all in square plus in 2x minus 1. Are you see now? So let us use top law on this and here. True or false? If we have in a raised to power n, this is the same thing as what? N in a. Amen? N in a. Okay, so our in y is equals to 3 all over 2 in open bracket x minus 2 minus open bracket 2 in open bracket x plus 1 plus in 2x minus 1 close the bracket. True or false? This is not a function. It is a constant, the same thing, because there is no x here. There is no x here. So we are not going to use product rule. You just differentiate this, use it to multiply this, differentiate this, use it to multiply this. So when we differentiate the left hand side, we are going to have 1 all over y dy all over the x is equals to 3 all over 2. If you differentiate in x minus 1, you are going to have times 1 all over x, or minus 2, sorry, x minus 2. Then minus open bracket, hold this one, differentiate in x plus 1, 2 times 1 all over x plus 1. True or false? Then plus differentiate in 2x minus 1. We are going to have 2 all over 2x minus 1. True or false? Yeah. True or false? It's true, right? So you close the bracket. Any question? I think I will attend to your question in class. Just write it down. Suleiman Bashir, write your question in your notebook. Is that clear? Then I will attend to you in class. Don't forget to remind me. It's okay. So what we need to do here is okay, I want to clean this side. Yeah. So here will be what? We cross multiply, oh? So our dy all over the x is equals to y open brackets 3 all over 2 times 1 all over x minus 2 minus open bracket, let's clean this, open bracket, open bracket, 2 times this is supposed to 2 times 1 is 2. You can still write this in this form, x plus 1, then plus 2 all over 2x minus 1, right? Okay, so y is this, the y all over the x is equals to, we write back this formula to replace y, so x minus 2 raised to the power of 3, then square root all over x plus 1 all in bracket square 2x minus 1, right? Then when you use 3 to multiply 1, 3, 2 to multiply x minus this, you are going to have 3 all over 2x minus 4, right? Now open this bracket, you are going to have minus 2 all over x plus 1, this times this, minus 2 all over 2x minus 1. This is what you are supposed to have, and this is the final answer. Any question, please? Do you have any question? I should throw more light on note that. Okay, I think this person, you came late. You did not start the class with us. I said note that. Let me clean this up so that you can see it better. Like where? Here. The laws. One of the laws is that if we have in open bracket a times b, this is the same thing as in a plus in b. Then when we have in open bracket a all over b, this is the same thing as in a minus in b. Then if we have in a raised to power n, this is the same thing as n in a. They taught you lots of logarithms now, two of us. So here, in open bracket x minus 2, close bracket raised to power 3 all over 2, we are going to make use of this law, two of us. That is why you are saying, we now bring this one down here. Then here too, the same thing, you use this law. That is why you are saying 2 in open bracket x plus 1, two of us. Then here, you can see that in AB, you can now see that two functions are multiplying each other, isn't it? Yeah, this times this. So it's going to be what? In A plus in B. So this is your A, this is your B. That is why you see in open bracket x plus 1, close bracket raised to power 2 plus in, can you see now? Are you following? So if you understand these laws, know when and how, where to apply them. Using logarithmic differentiation is simple as ABC. Is that clear? Any question? Is it not 2x 2 all over 2x minus 1? Which one are you talking about? Who is this person? Zuamba Emmanuel. Oh, plus. No, 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 no. Plus, where is the plus? No, now, we open this bracket, now look at it. Minus times this, we're going to give us, where is it? Okay, look at it here. Minus times this will give us minus 2 all over x plus. So minus times plus, is it not minus? Minus 2 all over 2x minus 1. True or false? If you open the brackets, Emmanuel, open the bracket and see. That is what you are going to get. So can we proceed now? I want you guys to like the video. Can we proceed now? Let's proceed. So when you come across questions like this, at least you don't need a prophet to tell you. Amen. Yeah, we have another one here. Another question here. Okay, so let's move further to solve the last question. Then I'm going to drop a good question for you guys to solve. Y is equals to x plus 1, open bracket, x minus 2 raised to the power of 3 all over x minus 3, right? Okay, so yeah, who can tell us what to do? We take log on both sides, right? We are going to have in open bracket in x plus 1 x minus 2 raised to the power of 3 all over x minus 3, right? Close the bracket. Then look at it, look at the board. Is that clear? So as you can see, which of the laws we are going to use first? That will be in y is equals to in open bracket x plus 1, then x minus 2 raised to the power of 3, isn't it? Yeah. Close the bracket, minus in open bracket x minus 3. True or false? Look at the boards. People should look at the board. Victor. Yes. Sorry for the break in transmission. Okay, so let's proceed. I hope you understand what I did here, because this one is dividing. If we have in open bracket a all over b, this is the same thing as in a minus in b. True or false? So look at it now. This is your b, this is your a. But here we are going to use if we have in a times b, this is the same thing as in a plus in what? B. True or false? So here, so our in y will now be equals to in open bracket x plus 1 then plus in open bracket x minus 2 raised to the power of 3 minus in open bracket x minus, right? Then here we are going to use, if we have in a raised to the power of n, is written as n in a, true or false? Here. So our in y is equals to in open bracket x plus 1, then plus 3 in open bracket x minus 2 minus in open bracket x minus 3, right? Okay, so if you can see what I am saying, we have to differentiate both sides. Y 1 all over y dy all over the x is equals to, if we differentiate in x plus 1, we are going to have 1 all over x plus 1, then plus differentiate in x minus 2, we are going to have 3 times 1 all over x minus 2, then minus differentiate in x minus 3, 1 all over x minus 3, right? So far so good, we cross multiply, dy all over the x is equals to y open bracket 1 all over x plus 1 plus 1, 3 times 1, 3 all over x minus 2 minus 1 all over x minus 3. True or false? Then what is our y? Our y, we go back to the function, is equals to, this is the function, right? X plus 1 open bracket x minus 2 raised to the power of 3 all over what? X minus 3, then open brackets 1 all over x plus 1 plus 3 all over x minus 2, right? Minus 1 all over x minus 3. This is the final answer. Any question before I drop the assignment? Yeah. Any question? Yes or no before I drop the assignment here? So that you go and kill yourself with it, and I'm collecting it tomorrow in the class. Okay, so if there is no no question, let me just write the assignment. Let me write the assignment here. Let me write it down here. Yeah. Let's see. Okay. Let's I can clean this. This is your assignment. Assignment. Okay, I'm getting it tomorrow. Probably I'm submitting. Use logarithmic differentiation to evaluate x raised to power 3 in 2x. I know you people will shout. You will say, Mr. Osi, I've started, right? Just kill yourself with this. Y is equals to, yeah. Then find dy all over the x using logarithmic differentiation, right? Okay, yeah. So, gentlemen and ladies, thank you for your time. I love you guys. I wish you a wonderful bed rest. See you guys tomorrow. Bye. Please don't forget to like and share. God bless you for your time.